If you've messed around with any AI chatbot recently, you probably know that the entire artificial intelligence industry has been sprinting in one massive unified direction. Basically, everyone's following the exact same playbook. But right now, one of the heaviest hitters in the game, Google DeepMind, is making a highly contrarian, multi-billion-dollar bet on a completely different path to artificial general intelligence, or AGI. So in this explainer, we are going to deconstruct exactly what they're building, why they are diverging from the pack, and how this could literally redefine the entire future of technology. Let's dive in. To really grasp the sheer audacity of this gamble, we kind of have to look back at DeepMind's history. Remember when the board game Go was basically considered unsolvable for an AI? DeepMind went all in on a project called AlphaGo, pouring in massive resources with absolutely zero immediate commercial return. And, well, they won that gamble. Today, CEO Demis Hassabis is treating AGI with that exact same philosophy. It's not just a software product, it's a long-term scientific mission to recreate the human mind. History is repeating itself right in front of us. DeepMind is tackling these huge, intractable problems that others are just avoiding. And depending on how this plays out, they're either executing an extraordinary masterstroke or they are making one of the biggest, most expensive miscalculations in modern AI history.
So, here is our roadmap for this explainer. First, we'll break down DeepMind's high-stakes gamble with the 4 pillars. Then, we'll look at how they're moving past pure transformers, dive into the diffusion model revolution, tackle the fascinating world model debate, and finally, look at their ultimate blueprint for AGI.
All right, part 1. DeepMind's high-stakes gamble. First, let's actually look at the standard blueprint basically everyone else is using to build AI today.
If you look at almost every major AI lab right now, their models are propped up by 4 main pillars. They are transformer-based, they are autoregressive, which basically just means they predict the next word or token, they are massively pre-trained, and they are generative. This right here is the exact cocktail powering the AI you probably have on your phone right now. And look, most researchers totally agree this specific combo has enormous potential, but it also comes with theoretical limitations that a lot of experts believe will actually prevent it from ever reaching true human-level intelligence. And that right there is exactly why DeepMind is already starting to tear these pillars down.
Which brings us to part 2, moving past pure transformers to solve a pretty massive memory problem.
So the standard transformer is incredibly powerful because every single token looks at all the other tokens to understand the context. But honestly, this quadratic cost scales terribly. Imagine reading a really long book. With standard global attention, by the time you hit page 100, you'd basically have to tear out the previous 99 pages and carry them around in this giant annoying stack just to understand the page you're currently on. It's a massive computational headache, and in the industry, this liability is known as the KV cache. But DeepMind's Griffin architecture completely changes this. Instead of dragging the whole book around, Griffin uses something called gated linear recurrences. Think of it like giving the AI a little index card. As it reads, it synthesizes the core meaning, continually rewriting and updating that single index card with an evolving state of past information. It is so much more efficient.
And DeepMind isn't just sitting around theorizing about this, they are actively shipping alternatives to either replace or complement that naive global attention. First off, they built Titans. This gives the AI a literal surprise mechanism, allowing it to memorize unexpected things for short-term memory, which is a massive step for continual learning. Then came Recurrent Gamma, which utilizes that exact index card Griffin architecture we just talked about. And now Gemma 4 pushes this to the absolute extreme. It handles a massive 256,000 tokens by intelligently mixing a local sliding window of attention, so for reading immediate paragraphs, with limited global attention to grasp the entire document. These aren't just minor product updates, folks. These are literal puzzle pieces for AGI.
Moving on to part 3, the diffusion model revolution. This is a parallel path targeting that second pillar.
Notice the clear contrast going on here. Standard autoregressive models generate text left to right, just one word at a time. It takes thousands of steps. Diffusion language models, on the other hand, start with a rough guess and refine the whole thing in parallel. This takes only tens of steps, making them significantly faster and honestly a lot cheaper. Plus, because diffusion works on the entire response all at once, it has built-in holistic error correction. It can naturally revise its own mistakes on the fly. And crucially, for complex tasks like writing code, diffusion models allow your prompt to sit absolutely anywhere. At an arbitrary position, it naturally sees the missing parts of a code block and fills them in. Whereas autoregressive models really awkwardly struggle if the prompt isn't just a fixed prefix at the very beginning.
Now, the crazy part is, most labs are just totally ignoring this. OpenAI literally shut down their diffusion-based video model, Sora 2, walking away from massive contracts just to go all in on autoregressive GPT tech. And yeah, pursuing both branches takes a massive amount of compute, but DeepMind, they are doing the exact opposite. They're maintaining an incredibly diverse tech stack, really leaning into their deep research bench. They've got Veo, Genie, Gemini Diffusion, the whole Imagen lineup at AlphaFold. They are placing a huge bet that keeping this parallel technological branch alive is absolutely 100% necessary for the next stage of AGI.
All right, part 4, the world model debate, in this really fascinating quest to cure what's called jagged intelligence.
Have you ever asked an AI a seemingly basic logic question and gotten just a bafflingly stupid answer back? Like, that is jagged intelligence. The model can literally win a math Olympiad, but then it tells you to eat rocks for better digestion. It lacks common sense, mainly because language is really just a lossy compression of reality. Think about the difference between someone who has read 1,000 books on Formula One racing versus actually being Lewis Hamilton. The reader knows all the facts, sure, but Hamilton has this embodied, physics-based, wordless internal representation of exactly how that machine interacts with reality. The human mind relies heavily on this wordless internal model. So if the ultimate goal is AGI, AI desperately needs this world model too. It has to understand intuitive physics, object permanence, and just basic spatial reality.
So how exactly do you teach a computer the physics of the real world? Well, you show it video. But right here is where we hit a massive philosophical clash between some of the biggest pioneers in AI. Yann LeCun, who is literally a foundational architect of deep learning, strongly argues that predicting the next frame in a video is intrinsically and mathematically intractable. To put that into perspective, the number of possible futures for just a single HD video frame makes the total number of atoms in the universe look absolutely tiny. It's just way too much math.
Because of that impossible math, LeCun advocates for something called JEPA. That stands for Joint Embedding Predictive Architecture. His core argument is that trying to reconstruct exact pixels is just a colossal waste of compute. I mean, you can't predict the exact random rustling of every single leaf on a tree. Instead, JEPA trains encoders to agree on a similar latent representation. Basically, if a ball rolls behind a physical wall, JEPA doesn't try to generate the actual video of the ball rolling, it just predicts a compatible future representation where the ball emerges on the other side. It learns the concept of object permanence without doing the impossible math of predicting every single pixel.
But DeepMind is taking a totally different counter approach here. They agree with LeCun that naive pixel prediction is impossible, but they've actually found a really clever generative shortcut. First, an encoder compresses the video down into a structured latent space, kind of like a compressed visual language that keeps all the underlying physics and geometry constraints intact. Second, a diffusion model learns to denoise within this frozen space. And finally, a decoder reconstructs it all back into realistic video. DeepMind's generative video models aren't actually trying to predict every possible pixel. They are exploiting the fact that real-world videos occupy a tiny, highly structured subset of physical rules.
So you might be wondering, why jump through all these crazy hoops just to make a video generator? Well, because these aren't just video generators. DeepMind is essentially building a hyper-realistic, matrix-like simulation of the real world using generative diffusion. And then they use that simulated world to train their multimodal AI, like Gemini. The massive revelation here is that a system like Gemini Omni is really an autoregressive core that's gathering rich physics-based experience inside a diffusion-based simulated world. It is literally building an explicit model of reality. And honestly, it is an absolutely fascinating concept.
Which brings us to our final section, Part 5, the pre-training divide and the ultimate blueprint for true AGI.
There are highly respected researchers out there, like Ilya Sutskever and Richard Sutton, who suggest that massive, rigid pre-training is actually biologically implausible, and it might even be a dead end. Just look at the contrast. Machine learning typically happens in these isolated labs with harsh binary rewards, simple success or failure. But humans, we learn continually with incredibly rich, nuanced signals. You don't need to actually crash a car to understand danger, right? You have this intuitive sense of balance and uncertainty the very second you sit behind the wheel. The argument here is that massive pre-training assumes the AI is just a highly inefficient learner. They believe true AGI should be a continuous learning algorithm deployed out into the real world, not just a finished, rigid, locked-in mind.
But DeepMind fundamentally disagrees with that approach. Demis Hassabis argues that to actually get to AGI quickly, it is only pragmatic to use all the existing human knowledge on the web as a foundation. Like, why in the world wouldn't you bootstrap the learning process with a massive pre-trained prior if you have the capability? This is the exact same philosophy that built their massive success with AlphaGo.
DeepMind completely believes that while human continuous learning is very elegant, taking deep learning's highly efficient pattern recognition, scaling it up massively, and pairing it with planning and search is for sure the fastest and most plausible way to finally crack AGI.
So we are ultimately left with this. While a huge chunk of the industry just continues to scale up the standard transformer blueprint, Google DeepMind is playing a highly specific, very contrarian hand. They are pushing way beyond naive transformers, they're keeping diffusion language models alive, and they are combining autoregressive logic with generative, physics-based simulated world models. So, are we witnessing an extraordinary vision of how intelligence actually works? Or is this massive diversion going to be the biggest, most incredibly expensive miscalculation in modern AI history? The wild part is, we are literally only a few short years away from finding out who is right. Thanks for joining me on this explainer, and definitely keep your eyes on the blueprint.